finish, and then I go through and see. Before I get into the group meeting, I want to make sure that I feel confident answering the group questions.
Yeah.
I hate being completely lost. So, and then I just end up doing it. And this time I wasn't going to submit it, but I was like, you know what? I'm pretty sure I got all these right.
You're like, I feel really good about this.
Like I double checked a few, and I was like, no, I think I got 100. So I submitted just to see, and sure enough, I got.
Wow.
So it's really not that difficult.
That's awesome.
Just need to understand connections for this one, really.
Yeah. Okay, so P bar, P is X over N. P bar is a point estimate of P. So the first question says, what is the symbol for the true population portion? The symbol for true population portion is which one? True population.
So P hat is your statistic. Your true population would be
just regular P.
Regular P.
There you go. There's like a P squiggly. Is that a thing, or is that just?
Nope. That is to throw you off track.
Okay. For the next two questions, suppose N equals 100, P is 0.25 NP. The requirements for construction of confidence interval are satisfied. Would that be true?
Yeah.
Okay. Confidence for conducting a hypothesis test are satisfied. Where?
Are you froze again?
Oh, did I freeze?
Yeah.
Oh, shoot. I noticed yesterday in the video, or when I posted on YouTube, that it didn't show my face.
At all?
Is that bad? Yeah, I don't think so, but like you could hear me.
No, I don't think it's bad. If you just outside of both of the small cameras, you should be able to pick. So when I talk, it should flash to me. When you talk, it should flash to you.
Yeah. It just stays on me.
Your main camera's looking.
My main what? Turn camera off. Let's do this. Not mute. Well, we'll see how this works. Okay. Let's do this. So the confidence interval is what we did yesterday, right? And then
sort of, yeah.
And then today we're doing hypothesis test.
We actually did. Instead of using the p-value in your calculations, you're using p hat. You're using your statistic.
So
if you can open up the textbook and you download the XLS, just the Excel spreadsheet, it's on this chapter.
Is it 2.3 categorical data analysis? Or there's?
I think so.
Okay, let me just.
I don't know because I'm. Oh, let me see if I can go back to it.
Okay, so for number 5, the hypothesis test is satisfied. Would that be true as well?
Yeah, it's under 2.3, and if you click that, it takes you to another page, and at the bottom of that page, there is an XLS. Don't click Windows or Mac, just the SLS, the Excel spreadsheet at the bottom. If you open that.
Okay. Are you in Rexburg?
Yeah. We just have crappy internet.
You cut out.
I know.
I don't know if I cut out or if you cut out. Oh, well, where'd you go? Okay.
Can you see me now?
Yes. I think you're frozen, though. Okay, there you go.
Okay.
I see you now.
Yeah. We both keep periodically cutting in and out.
So. Yikes. Okay, so number 6. Find P bar, round to 3 decimals. So when does this little categorical data analysis.
Oh, it'll do it right now.
Wait, did you just tell me where you lived?
I live in Rexburg.
Okay, like in what complex?
Draper Oaks.
Draper Oaks. I don't know where that is.
It's just down the street from North and South Gate.
Oh, okay. Cool.
South. It's pretty close.
Okay, so it opened 5 or 6 to find P bar.
So P bar is
How
just
do
X
we-
over N, and if you just enter in X and N, it'll give you. It's called P hat. Let's see a little
P hat.
Yeah.
P hat. Okay, so a simple random sample of 60 people, 45 were found guilty. So
Right.
how do you tell which one is which? Oh.
So your sample size. The simulation, which would be 45, which is your X value.
Okay,
so X
45
is 45. Yeah, and
45, and then N is 60?
Yep.
And then you just push enter, or does it automatically do it?
You may have to push enter, but
Okay, let's see.
so then you should get a bunch of readouts. You don't need to worry about the other stuff right now, but you can see what P hat is automatically.
P hat is 0.750.
Perfect.
Okay, I did it right.
Yep.
And then create a 95% confidence interval for the true population of first-degree murder trials in the state. There was a verdict, guilty. So would margin of error already be on here?
No, so margin of error is the only one you have to calculate. But margin of error, remember, if you have your upper and lower bounds, which if you look on the Excel spreadsheet, it shows the confidence interval, and under that there's 0.640 and 0.860.
I'm trying to find those. Okay. So I have confidence interval is 45 and 15. Does that sound right to you? Or 42 and 18?
What?
Oh.
It should say 0.640.
0.64. Mine does. Okay. Confidence interval. So you just subtract the upper bound and lower bound?
No, so the lower, remember that the margin of error is your P hat value plus or lower bound. Does that make sense?
You cut out on the last part.
So your upper and lower bounds are P hat plus or minus the margin of error. So
Okay.
I do the difference. So I take the lower bound and I say, what is P hat minus the lower bound should give you the margin of error. Does that make sense?
Okay. Would it always be the lower bound?
You can do the upper bound too. You just have to add. It would be, well,
So
yeah.
it would be 0.860 plus 0.750.
Minus 0.750. But if you do the lower bound, then it's 0.750 minus 0.64. Does that make sense?
Yeah. So 0.750 minus 0.640. So 0.11.
Yep.
0.11.
And then you have the answers for 8 and 9.
Input the lower bound. That would be the 0.640.
Yep.
And then 0.860.
Yep.
0.640. 0.860. Okay. And then 10 and 11. Oh, we're almost done. Well, never mind.
We're close. It's not hard.
I thought it went to like 15. I'm like, oh, we're almost done. Okay. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? Would it decrease?
Yeah. So if you increase the sample size, it decreases. If you increase your margin of error, then it will increase.
Okay. To conduct a hypothesis for one portion, 2 requirements will be met. What is the smallest n can be? Didn't you say you like times that by like 1.25? or something? Is that a different question we did yesterday?
No, so that's from yesterday. So basically, that's the whole n times p must be greater or equal to 10, and so must n times 1 minus p. So I just do it backwards. So if your p is 0.5, I do 10 divided by 0.5 gives you what? And then I plug it back in to make sure it works.
20?
Yeah.
Okay.
And 12 is the same thing, just with 0.1 instead of 0.5.
So you should do 10 divided by 0.1?
Yep.
Which is 100.
Yep.
Okay. Use the following information. The conditions for conducting a hypothesis test is satisfied. So they have 80 and 38.
Plug all this into your Excel sheet, and then there should be an option for what the null hypothesis equals, and then what we're going for, which is less than.
38 and n equals 80. The null hypothesis, we want it to be 60.
Yep.
Oops,
0.6, yeah.
0.6. Okay, and then we want it to be less than.
Yep.
So let's see. So the conditions for is satisfied. That'd be yes, correct?
Yeah, and you can tell that.
Because we could enter everything in.
Plus the second thing on your Excel spreadsheet is confidence interval requirements, and it says both greater than 10. As long as those two numbers are greater than 10, then you're good.
Okay, that makes a lot of sense. Okay, 14. What is P bar? That's or P hat 0.475.
Correct.
Wow, I like this thing.
Yeah, it's really like there's 3 videos this time, and the videos are a little convoluted, but if you use the Excel spreadsheet, it's super simple.
Yeah. So test statistic.
Yep.
What formula, or is that already there?
It's already there. It's the Z value under the 1 proportion Z test.
Okay, I need to remember that. Test statistic is negative 2.282.
Yes. And the lesson does go over all the math for this, so you should go back and do it all. But
yeah, and figure it out.
It's the math we've done before, and he said we'll be able to use the Excel spreadsheet on the exam as well. So,
what's the p-value for this test? 0.011.
Yep.
All right, what is statistic? Okay, this is what I have a question with.
Okay.
So if it's less than 0.05, then you reject it, or do you fail to reject?
You reject it.
Okay, and then if it's greater, you always fail. So
yes.
Listen.
And their little saying was if the p-value is low, reject the null. It doesn't rhyme, but
well, it makes sense, kind of.
Yeah, it thinks that.
Okay, and then so you would say you would have sufficient evidence, or there's insufficient?
There is sufficient evidence.
Because it's less than that.
Yep, that it has decreased.
And then insufficient if it's greater than that. Wait. Let me see if I got that right. So if it's greater than 0.05, we reject it. Or if it's less than 0.05.
Lower than. Reject.
Okay, so I totally wrote that wrong.
So if basically you're saying there's sufficient evidence, you're either, this is where it gets confusing, because when we talk about null hypothesis, we either reject the null or we fail to reject the null.
Mm-hmm.
And just kind of keep that in mind. If we're rejecting the null, then there is sufficient evidence to go somewhere else.
Okay.
If we're not rejecting the null, there is insufficient evidence to go somewhere else. It's always about the somewhere else. So if it was higher than the 0.05, then there would be, insufficient evidence to conclude that the water quality in the area has decreased.
Okay, so for that one, let me see. So it's less than, so it'd be there is sufficient evidence to conclude that the water quality in this area has decreased.
Yep.
Okay. All right, that's it.
Yep.
Okay, we got it.
Sweet.
Cool. So I'll stop broadcasting this, and then we'll talk about the group meeting.
Yeah, that sounds good.